Hi, my name is Kestenbaum. I'm responsible for sales and marketing here at SimPlan, and I would like to introduce my colleague, Dirk Steinhauer, who is an expert in the area of one-off production. And I would like to talk to him about simulation in this area, and I also would like to ask him to answer all my questions I'm typically asked from my customers about this in this area, because he's a very experienced person, and I would like to ask you to introduce yourself.
Thank you, Harry. Yeah, my name is Dirk Steinhauer. I'm the manager of the North Branch in Hamburg of SimPlan. And before I joined SimPlan, I was working in the industry at the shipbuilding company for more than 20 years. And also doing the simulation in one-off production, also cooperating a lot with civil engineering. So that's basically my background for today's talk.
Thank you, Dirk. So let's start with some questions. Of course, we are prepared, and I have written down some of the typical questions we've been asked about this. So what type of simulation we are talking about, and what is so specific about it?
Yeah, today we are talking about discrete event simulation, which is basically determining the different states over time of a specific system. So we monitor a system over time, not a static situation, but what happens in a production and logistics process. And this is an established technology for standardized processes like automotive logistics centers. And it is something to use for assuring investments or also supporting planning and control, I would say.
Mm-hmm. Thank you. So, yeah, typically automotive logistics whatsoever. So is this kind of simulation used also for these already mentioned complex one-off productions such as structural or civil engineering, shipbuilding, or steel construction?
There are applications, definitely, indeed, but rarely used. It's not an established technology, I would say. We do have specific problems where simulation is involved, but not really all the time as it is done like in the automotive industry or logistics centers.
Mm-hmm. What makes simulation in one-off productions so challenging?
Basically, it's of course the very complex process, and the process is of course determined by the very complex product. And this is of course something which makes it very specific. We do have, of course, a lot of dependencies. These dependencies, constraints may also change over time. We have specifically in the construction industries, civil engineering, shipbuilding, and also the building of complex machines, engines. We have the situation that we have a lot of site production instead of a flow line production, which is something, of course, which is very flexible. We have a lot of possibilities for determining the process. But on the one hand, is of course very, very complex to plan, to schedule, to monitor at the end. And in specific phases of this complex one-off production, the product itself equals the production environment. So we are like producing inside of the product, and which is also changing a lot of constraints over time in a very limited area, most probably.
So what's about the various resources you have talked about, how they are involved in these kind of processes then?
Yeah, we do have a battle of resources because we have a lot of different requirements at specific points in the process, at specific locations of the process. If we are looking at a specific site or a specific building that we are currently focusing at. And this is, of course, something which is quite hard to handle. And every change of location for a resource is always a specific time, a setup time, which is, of course, losing money at the end.
So that's the difference. So simulation is typically used for automated processes, so that's what people are thinking often. So what about the manual processes you will find in the one-off production? Isn't it hard to evaluate those process times then?
Indeed, that's very often a very interesting challenge to get reasonable times for what we are doing on a very complex site. But it is impossible, especially regarding the manual process, to really determine them by the second or by the minute maybe, because there are so many dependencies of the production environment, the material, the quality, whatever, on the process time that we are talking about. I am personally convinced that it is not really the focus of efficiency that we usually have in one-off production, but on effectiveness, meaning that it is not really worth looking at the single process in a very complex production area and to optimize the single process in a very complex production, but on focusing on that everyone should do the right thing at the right time at the right location. This is, I think, the most promising approach of optimizing one-off production. It does not mean like doing one thing is not leaving the other. It is also worth unlocking some of the processes in detail. But basically, I think it's better to organize the process overall to have an overall performance that is reasonable at the end.
Understood. So manual processes is one challenging. The other thing in the discussion is always, are these one-off productions far too complex to have a simulation? So how you can measure the influence of dynamic effects if you have just one try in production?
Yeah, this is a question which is asked quite often. It is, of course, a very interesting question. Personally, I think the more complex a process gets, the higher the risk is to lose the control on the process and also to fail at the end with the process. And that's why I think it is not really an obstacle. It's a reason to use the simulation because, well, as a project manager of a very complex process, it is extremely important to stay in control of the process. And simulation can help there a lot by evaluating the process in all phases, in the planning phase as well as in the operation phase.
So the use of simulation in one-off production makes sense. But can you be more specific on that?
Yeah, I mean, the use of simulation in one-off production is, of course, supporting, first of all, the design of the process, like doing feasibility analysis. Is it possible to do the project as I want? Is it possible with the resources and the constraints that I usually face? That's one very important aspect, and simulation can help there a lot. And also, if I'm going more specifically into the scheduling, planning phase, operational phase, it is, of course, extremely important to use these tools to stay in control, to have the idea about different alternative variants, to try it in one way, try it in another way. You can only do that in the simulation in a one-off process because the real process is only done once. So that's really a very important aspect in doing so. And of course, in these complex processes where you also often have the risk to lose the control, it is very interesting to look at the robustness of a plan. Is it possible to also cover specific disturbances that I have, material loss or loss of resources, any kind of disturbances that I have? What will have that? What impact will that have on my production process? And this is also something we can easily analyze in a running simulation model.
So I think we understand what is the benefit of a simulation. Coming back to what kind of challenges we have to do such a simulation, and you as an expert, what kind of challenges you are facing all the time when you do such projects?
Of course, these kind of projects, of course, often have the need that we determine the process, the one-off process from scratch. And this is, of course, something we need to avoid, because the main benefit of simulation can only be used if we are on time, right? It doesn't make any sense to be ready with a simulation model when the project is over. So reducing the effort is something we extremely after, and this is something that we are focusing with tools that we develop. We have developed already. We have a lot of tools regarding the simulation, the data management, but also we have ongoing research on reducing the effort for one-of-a-kind production simulation.
So what further applications do you see for simulation in one-off production?
Well, basically, the main idea is, of course, to enable a reasonable project for this one-off production. So it is something we can use in a strategic way, of course. But I think the main focus of using simulation in one-off production is more at the planning and operational phase. So we have always a specific process, so we need the specific simulation for this project, and we can support it in many ways during the production and also, of course, in planning it.
So we talked about the topic in general. Let's be more specific about SimPlan. So what does SimPlan offer in this respect to customers like shipbuilders or steel construction companies?
Well, we do have a lot of experience in that field, which also results in specific tools that we have available. Starting with the data management, we have data structures, especially for one-of-a-kind productions, which are supported by specific data management tools, which enables us to collect data from customers very easily and structure them in order to have the right simulation data. And then, of course, we have a simulation library, the STS library, which we developed for 25 years now, which is used to specifically model one-of-a-kind processes. It started in shipbuilding, but it is now also used in many other industries, civil engineering and steel manufacturing, whatever. And this is something, of course, we can bring into these kind of projects for bringing the project also to the success at the end.
Let's go more in detail, especially because of your history and the history of the already mentioned STS library. Let's go more in detail in one branch. So what makes simulation special in shipbuilding?
Yeah, shipbuilding is a very typical one-of-a-kind production industry, I would say. We have a lot of these challenges that I already mentioned. Of course, we have some differences regarding the comparison to, for example, civil engineering. At the shipyard, I usually have the shipbuilding site at my own facilities, so the logistics is clear, especially regarding the logistics to the site. That's, of course, a very big challenge in civil engineering. We have another technology than in other industries, of course, specifically in shipbuilding. But we do have a lot of similar challenges regarding the outfitting, the interior fitting, the same challenges as the civil engineering has.
Okay, so these are the challenges of the shipbuilding. So let's be more specific again about the challenges for the simulation in shipbuilding.
Yeah. In shipbuilding specifically, we have already solved quite well the modeling part of the simulation. So we do have this STS library, and this enables us to build simulation models of shipyards with a reasonable effort. I would say the main challenge you usually have in shipbuilding projects is the data collection, the data preparation of data from the product, from the planning, from the engineering, which is always a very interesting point at shipyards. So this is something which is usually the biggest challenge, but again, we have already a specific data structure. We have data management tools which we can use quite easily in that respect.
So that's the challenges of simulation, which you're facing all the time, but from your experience, what kind of applications are already implemented in Shipyard from your experience?
Well, we have, of course, cases where we want to improve existing shipyards, building new facilities, new technology in use, welding robots or anything like that, automation, basically, where simulation is, of course, used to assure that the result is as expected. In that speed. These strategic, I mean, we have rarely also have greenfield shipyards, but of course that's not very many cases. But we had these kind of projects. More interesting is to support the planning and control of shipbuilding process, meaning to use the simulation every week, every day, depending on the related production station, to control the manning level, to control sequences, to control building site allocations, and all of these kind of support that can be done by the simulation.
So as I already mentioned, you have a lot of experience in this area. So you're doing simulation for almost 30 years now. Can you give us some application examples in detail you have?
Well, we did have very interesting greenfield simulation studies about shipyards that wanted or that should be completely built anew on a green field, which is very interesting because it also reflects the specific layout optimization. And of course, we can also provide experience in that respect because we have done a lot of those projects overall. So these strategic processes have been very interesting. We have customers that use the simulation specifically for the site allocation, meaning they have a lot of building sites on the shipyard, and it is interesting to allocate these sites in a reasonable way. All these sites have different constraints and dependencies, and it's very interesting to have a specific scheduling tool, especially if you think about specific disturbances on one building site may result in a complete new scheduling of the full factory. So this is something which is very interesting as well.
So is there any chance to have a closer look on the simulation approach of SimPlan for shipbuilding?
Definitely. We have developed with partners of us a shipyard simulation demonstrator, which covers the full process from part manufacturing on section assembly, block assembly, painting, to the final assembly at the dock and the outfitting at the pier. And this simulation demonstrator is downloadable at our site, at our website, and is also runnable without a license as a pack-and-go version. So there everybody can have a look. And if there's any further questions, please let us know. So
please download the Shipyard demonstrator, have a closer look on our website, www.simplan.de. And so I think we are more or less through our list, through all the questions. Thank you for answering all my nasty questions.
You're very welcome.
Thank you for having the time, and we thank you, watchers and listeners, for watching us, and we hope to see you somewhere and somehow and some time. Thank you very much.
Thank you. Bye-bye.